Hello and welcome. This is the main menu of the STATEQ1 program. We're going to go deep dive here. So let's go to descriptive statistics. We have the mean is the sum of values divided by the number of values. So here, this pound sign is not going to be a hashtag, but rather a number. So basically, sum of values of a number of values. Mean from a frequency table is sigma, which is the sum. That's the Greek letter sigma, which usually indicates a sum in mathematics. It's f times x over the sum of f, all the values there. Now, the median for an odd number of numbers, n is the number of numbers you have, it'll be the middle number. But the median for an even number of numbers will be the average of the two middle numbers. The mode is the most frequent value. So for instance, if you look on your phone and you see the person you most frequently called, that would be the mode of calls that you make. Like for instance, it might be your mom, might be boyfriend, girlfriend, something like that. Okay, and then the range in values is going to be the max value minus the min value. The variance, and there's this little sigma. It looks like a zero with hair coming out the top. So that's a sigma, and sigma squared is going to be 1 over n again is the number of values, times sigma, and again that's the sum of x1. x1 is any value you have, like x1 is your first value, x2 would be your second value, x3, etc., minus x bar. Now usually x bar is written like this, x with a bar over it. I write it x bar here so you guys can see it more clearly, because I don't have an x bar symbol as far as I know in the TI84 calculator. And it's going to be the sum of that value minus the average value squared. And if you look at standard deviation, that sigma without the squared, basically it's just the square root of variance. And it is for in a lot of other areas in statistics. So let's go on. We go to probability. Probability of events. We have the probability of E is the number of favorable outcomes divided by total number of outcomes. So for instance, the typical thing is if you have like 3 green marbles in a jar of 10 marbles, you have 3 of the marbles that are green divided by 10 marbles. So that would be 3 over 10, which is 0.3. Now, if we go towards different types of events, we have probability of A or B is going to be the probability of A plus the probability of B if A and B are mutually exclusive. So for instance, let's say there's a 30% chance of rain tomorrow. That would indicate there's a 70% chance it won't rain, which are mutually exclusive events. Either it rains or it doesn't. So probability of A would be 30%. Probability of B is 70%. That would be 100% of it rains or doesn't rain. But then if you have something not mutually exclusive, probability of A or B would be probability of A plus the probability of B minus probability of A and B. And this A and B here means the overlap. Then if we talk about another type of probability of A and B, meaning they both happen at the same time or both happen in an event, it's probability of A times probability of B if they are independent. But then it's probability of A and B is probability of A times probability of B given A. That's what this vertical symbol means here, this vertical line. Probability of B given A if A and B are dependent. We go on, okay, and let's talk about probability, permutations, and combinations. So this permutations formula is none alike. That's what this stands for here. Probability of n comma k is n factorial. That's what this means. And the factorial n factorial is n times n minus 1 times n minus 2 times all the way 2 and 1. So for instance, 5 factorial would be 5 times 4 times 3 times 2 times 1. It's usually an integer value there for n. So permutations formula for n1 and 2 alike. Combinations formula, we have c n comma k is n factorial divided by, and this whole quantity, k factorial times n minus k factorial. So let's say we did 5 comma 3, n is 5, so it'd be 5 factorial over 3 factorial times 2 factorial, because 5 minus 3 would be the 2. We go on. We talk about distributions. We have probability and binomial distributions. So mean probability distribution, mu is sigma, the sum of x times probability of x. And standard deviation, sigma equals the square root of the sum of x squared times probability of x minus mu squared. Mu is typically an average of some sort. And then we have binomial probability. P of x equals, okay, this is n factorial times p raised to the x times q raised to the n minus x. Again, p is probability of something happening. Let's say it's 30%. Q then would be 1 minus p, so that'd be 70% right there. We're plugging that in here. N minus x factorial times x factorial. Now mean, again, this is mean for a binomial distribution, is mu equals n times p, also called the expected value. And then we talk about variance in a binomial distribution is sigma squared is n times p times q. And then standard deviation, again, usually it's just, again, the square root of the variance, which you'll see right there. Probability of success, p. P is probability of success each trial. Let's say, again, 30%. So probability of failure would be 70%, which is 1 minus that 30% there. Then we go on to distributions. We talk about normal distributions here. So z-score is x minus mu divided by sigma, or z equals x minus x bar over s. Now it depends if you're talking about a population or sample. You can get into that later in other videos, but dividing by sigma or dividing by s, excuse me, it depends whether you're doing a population or a sample population. Central limit theorem, mu of s equals mu. Again, you can look in your book to more explanation of that. So central limit theorem with standard error, sigma of x is sigma divided by rad n. N is the number of events you're talking about, or number in the sample or population, I believe. Okay, then we go on. I think we're on to confidence intervals here. So I have confidence intervals 1 population, confidence intervals 2 population. So let's talk about confidence intervals 1 population. We have a proportion. This is p hat. I don't have that symbol available to me on the TI84. So it's p hat minus e. Usually e is the error. Is less than p hat plus e, where e is z. And this is alpha over 2, that symbol. You'll see it on charts in stats books. Divided by p hat times q hat divided by n. And then we talk about the mean x bar minus e is less than mu, is less than x bar plus e. Again, I believe that's margin of error, where e in this case is t alpha over 2 times s divided by rad n, where sigma is unknown, or e is t alpha over 2 times sigma rad divided by rad n, where sigma is known. The variance is going to be n minus 1 times s squared divided by chi squared, excuse me, to the right, is less than sigma squared, is less than n minus 1 times s squared divided by chi squared to the left. That's more like a chi squared test, I think. And then we go on to confidence interval 2 population. I just did the basic one, which is the p hat 1 minus the p hat 2 for the second population, minus e is less than p1 minus p2 is less than p hat 1 minus p hat 2 plus e. And e is this t alpha over 2 rad square root of basically p hat 1 times q hat 1 divided by n1 plus, gosh, p hat 2 times q hat 2 divided by n2. Oh my goodness, that's a lot. Okay, so then let's talk about sample size determination. So proportion, where p hat and q hat are unknown, n is z alpha over 2 squared times 0.25, all divided by e squared. Now that's where, again, p hat and q hat are unknown, but the proportion for p hat, q hat known, when n equals z alpha over 2 squared times p hat times q hat, because again, p hat and q hat are known in this case, divided by e squared, and the mean would be n equals z alpha over 2 times sigma divided by e, all that squared. Oh my goodness, so much to memorize in stats. I'm glad that I made this program. Okay, then 6 for test statistics. For 1 population, the proportion would be z equals p hat minus p divided by the square root of p times q. Again, p is probability it happens, z q is probability it doesn't happen, divided by n. The mean for 1 population, where sigma is unknown, t is going to be x bar minus mu divided by s divided by square root of n. And then the mean, one population where sigma is known. Z would be x bar minus mu divided by sigma over rad n. And standard deviation or variance for one population, chi squared is going to be n minus 1 times s squared divided by sigma squared. And then x bar is the sample mean. And this little, like, looks like a cross between an m and a u is actually a mu. And its population mean. N is, I think, number in your sample, or number in, yeah, sample size. Okay, and then we'll go on to various test formula. We're talking about z-test here. So the z-test formula is going to be x bar minus mu divided by sigma over rad n, where x bar is sample mean, and then mu is population mean. Sigma is population standard deviation, and n is a sample size. Just to give you a definition of all this when you're plugging it into your calculator. We go back to the various test formula, and let's look at a t-test. T-test formula for one sample is x bar minus mu divided by s divided by rad n. X bar is a sample mean, mu is population mean, s is a sample standard deviation, and n is a sample size. Then we go on to the various test formulas, and then we have the chi-squared test formula. Chi-squared test formula is a goodness of fit test, and chi-squared is sigma the sum of O sub I minus E sub I squared divided by E sub I. DF means degrees of freedom. That's a thing I never got until a classmate pointed it out to me in a stats class. And that's K minus 1. And then the chi-squared test contingency table, degrees of freedom would be R minus A, that times the quantity C minus 1. So it's rows minus A times C minus 1. Or I believe it's rows minus alpha. I'm not quite sure. You can look that up. I'll probably post an explanation before I post the video. Okay, chi squared again is sigma O of I divided by E sub I squared over E of I, where chi squared is the chi-squared test statistic, and O is the observed frequency for category I, so it's O sub I, and E sub I is expected frequency for category I, so it's observed observed is O, E is the expected, and sigma is summation indicating sum, and DF is degrees of freedom. So E is row total times column total divided by grand total. Whew, it's a lot to memorize if you don't have this. Oh my goodness. Okay, then we go on to hypothesis testing. This is basic stuff for hypothesis testing. I don't mean to say it's a basic thing, but this is just truly the basics. There's a lot more to it. Null hypothesis is H sub O, where P is some number. Probability, usually it's like some decimal, like 0.2568 or something. Alternative hypothesis, that's signified by H sub A. Now, H sub A is greater than some number, or H sub A, the alternative hypothesis, is less than some number, or H sub A doesn't equal some number. Now, so just keep in mind, HO is equality, HA is some inequality. So HO equality, HA inequality. Okay, going on, p-value falls within a critical region, usually the outer area of a curve, then we reject the null hypothesis. If p-value falls within the middle area, typically the middle area of a curve, there's two-tailed tests and one-tailed tests, a left-tailed and a right-tailed. I don't want to get into it. It's more extensive than what's covered in this program. But if p-value falls in the middle area, typically, then you fail to reject a null hypothesis. Usually, and this is usually, there are exceptions, if the p-value is less than or equal to alpha, you reject the null hypothesis. Conversely, if p-value is greater than alpha, you fail to reject the null hypothesis. Oh my goodness, that is everything of this program. It doesn't have everything in a basic university stats class or AP stats class, but definitely a help. I mean, this will definitely help you pass a stats class. It can definitely help you get an A if you're an aspiring student and you're working towards an A. But we will have revisions of this. This is STATEQ1. STATEQ2 will have changes that you put in your comments. Say like, hey, I would like this added to the program, or this clarified, or this definition added, or this formula added to your program, I will add it. But this was a monster to create because it has so many screens. So look, good luck in all your math endeavors, and I'll see you next time.